Hello and welcome back. In this video we will start looking at derivatives of exponentials. So what have we learned rules about of taking derivatives so far? Well, we've obviously seen the initial definitions involving limits, but then we use those definitions so that we can take powers of x. So we can take the derivative of x to the n or anything like that. We can take derivatives of sums and differences of functions. So for instance, anything, for example, that looks like x to the n plus x to the m. We can take products of functions. So I could take the derivative of x squared plus 1 times x cubed minus the square root of x. We've seen how to take the derivatives of quotients of functions. So again, anything where we're dividing functions, and compositions of functions where we put functions inside of other functions. So maybe we have the square root of x squared plus 3, where the outside function is the square root function and the inside function is going to be x squared plus 3. So we've seen how to deal with a lot of these, but they mostly involve just powers of x combined in some way, shape, or form. So today we'll look at derivatives of exponentials, which are not simply going to be a power of x. So when we want to take the derivative of a to the x power, this is pretty straightforward. It is nearly the same thing. It is a to the x power times the natural log of a. And that's it. This natural log of a pops out. And we can do a couple of quick examples here. If we take the derivative of 2 to the x power, again, this is just going to be 2 to the x power times the natural log of 2. So it increases by a little factor. Here the natural log of 2 is going to be a number that's slightly smaller than 1. So we're just sort of squishing down this exponential 2 to the x power. If we have 10 to the x power, again, the derivative is just going to be itself times the natural log of 10. And that's all there is to derivatives of exponential functions. However, we can start combining exponential functions using all of the rules that we've already seen. We can throw in some powers of x, we can add it to things, take products with it, divide it by things, and take compositions. So let's look at another example here. We've got the derivative of 7 to the x plus 1 power. So when I look at this, maybe off to the side, when I see 7 to the x plus 1, what I have is sort of an inside function and an outside function. So it's as if I'm composing 7 to the x power and x plus 1. I'm plugging x plus 1 into my function here. So what I'll do to take the derivative of this is I'll take the derivative of the outside function. The outside function is 7 to the x power, so the derivative is going to be 7 to the x plus 1 times the natural log of 7. This is just the derivative of 7 to the x, but with x plus 1 plugged in. And then I need to take it times the derivative of what's inside the function. So this is just going to be the derivative of the 7 to the x part with x plus 1 plugged in. This is going to be the derivative of the x plus 1 part. So this is just the regular chain rule. And when I do this, let me those. What is the derivative of x plus 1? Well, the derivative of x is 1, and the derivative of 1 is 0. So derivative of x plus 1 is going to be 1, and 1 times anything is just itself. So let me do this in one other way, and this will sort of make sense why it is just 7 to the x plus 1 times the natural log of 7. Again, over here in some scratch work, I'm going to take 7 to the x plus 1, and I'm going to rewrite this as 7 to the x times 7 to the first power. When we multiply exponentials with the same base, we get to add the top together. So over here, this is going to be 7 to the x times 7 to the first power. Well, that's just equal to 7. This is just 7 times 7 to the x power. So if I want to take the derivative of 7 to the x plus 1, it's the same thing as taking the derivative of 7 times 7 to the x. When you take the derivative of a constant, it just comes out. A constant times a function, you can pull constants out. So this is just going to be 7 times the derivative of 7 to the x, which is going to be 7 times 7 to the x natural log of 7. And I can then consolidate these guys in the same way that I did over here. If I take 7 to the x times 7, I get 7 to the x plus 1. So our answers match. There's more than one way to take a derivative of these exponential functions. Let's do this guy here. We have the derivative of x to the minus 3. And again, I'll do this in a couple of different ways. So first of all, sort of off to the side over here, we'll notice that 3 to the negative x, this is going to be the composition of two functions. I've got 3 to the x, and I'm plugging in a negative x into there. So here's my outside function, here's my inside function. So what I will do is I will take the derivative of the outside function, just like I would in the chain rule. So the derivative of 3 to the x is going to be 3x natural log of 3. Again, natural log of 3 is just a number, but I'm going to plug my negative x in there. And then I'm going to take the derivative of negative x. So again, this is the derivative of 3 to the x with a negative x plugged in. This is going to be the derivative of my negative x part. So I just have the chain rule in here. And 3 to the negative x times the natural log of 3. The derivative of negative x is in fact negative 1. So I might put that negative sign out front, and we'll say that we'll get negative 3 to the negative x power times the natural log of 3. Okay, so there you go. That's it. However, one thing that we could do is we could do this the hard way, which I might just as an example. The other thing to notice about 3 to the negative x is that this is the same thing as 3 to the x to the negative 1 power. Whenever you take an exponent, an exponential function, raise it to another exponent, we multiply what's inside. So here, I could use a chain rule. So the derivative of 3 to the negative x is going to be the same thing as the derivative of 3 to the x to the negative 1. If I raise anything to the negative 1 power, the derivative of that is going to be, I bring down the negative sign, this is going to be negative 1 times what's inside to the negative 2nd power. Again, I'm going to raise it to the 1 fewer power. So negative 1, instead of raising it to the negative 1, I'm going to raise it to the negative 2 power. And then I'm going to take it times the derivative of the inside. So I'm going to take it times the derivative of 3 to the x. Well, that part is easy. So I'll have negative 1 up front times 3x to the negative 2. And then the derivative of 3 to the x is 3 to the x times the natural log of 3. So we're nearly done because I've got my negative sign for multiplying by -1. I have 3x to the -2 times a 3x, and this is going to be 3x to the -1. I've got -2 copies over here. I've got 1 copy over there. When we combine them, we get -1 copies. All this times the natural log of 3. And simplifying this, we get -1, 3 to the x to the -1, and then times the natural log of 3. So we get the same thing both ways, but I think this top way is probably a little bit easier. Let's just keep doing more functions. So I have the derivative of 6 to the 3x squared plus x. Okay? So again, what you'll notice is that I have a 6 to the x, but I'm composing that with 3x squared plus x. I'm taking this function and I'm plugging it in to my 6 to the x power here. So I'm just going to do this just like this, where using the chain rule, I need to take the derivative of the outside function. So the derivative of 6 to the x, which is my outside function, is going to be 6 to the x times the natural log of 6. However, I have to plug back in my inside function. So it's going to be 6 to the 3x squared plus x, and then all of this is going to be times the derivative of the inside. So again, what I have out front looks like the derivative of 6 to the x, because that's my outside function, and the rest is the derivative of 3x squared plus x, which is the inside function. Cool, so let's simplify this. Well, 6 to the 3x squared plus x times the natural log of 6. And then over here I have the derivative. So the derivative of 3x squared, so the factor of 3 just stays there, and the derivative of x squared is going to be 2x. And then the derivative of x is just going to be 1. So after I simplify this, I'll get 6 times 3x squared plus x times the natural log of 6 times 6x plus 1. And there you have it. That's how simple it is to take the derivative of an exponential function. And I think I will stop here and just do more examples in the next video.